So in this demo, I'll show how we can aggregate different data points that can exist independently into multi-level aggregates and how we can retrieve data from these aggregates. So the dataset I'm working with is a garment workers productivity dataset from Cargo. And it has some features here, a couple of features actually: date, quarter, department, day, team, target productivity, SMV, which means standard minute value, work in progress, overtime, incentive. So these three are mostly zeros, so we're going to use them, the number of workers and the actual productivity. So a typical machine learning task for this dataset is to predict this actual productivity. And we'll see how we can achieve the same goal, but using the methods of retrieval while working with a multi-level aggregates. So that's going to be the goal of this demo. So let's go right into it. So here I'm just going to make some quick imports to bring in the Python AveniECA SDK. And then we create a data frame from our data set. So there are two ways you can get data into your ECA instance. So either you stream over a message broker or you can write directly to your ECA database. So for this demo, we're just going to write directly using the REST API, write the data directly into the ECA database. And check out the demo on Smart IoT to see how we can use a stream over a message broker to sync with our digital twins in real time. So here we're going to create ESS and sequence for each of those features in the database. And this might seem counterintuitive, or you might just be wondering why we want to treat each of these features as digital twins. And the reason is because although they exist in this data set currently, they've been cleaned up and they're collected together here. But you can imagine that you should think of it as these features as independent data sources that might be coming from different places or different sources. So what we want to do is to treat them as independent ESS that have their own storage. And this is useful when we start to think of aggregates. So we create ESS and sequence for each of those features. Now, what is an ESS? It is an emotified state signal, which is the primary data structure in AveniECA. So the sequence is the other one. So if you think of the ESS as the state, the sequence models state-to-state transitions. So here we're using this utility from the SDK to create both the ESS and sequence. And we're passing in the data that we're getting from our data set here, and also the twin configurations for which we have already created. And then I'm passing in an embedding API to create vector embeddings for the states that are text-based. So we do that for the date, the quarter, the department, the day, the team, SMV, WIP, the incentive, and number of workers. Once that's done, we can then create an aggregate of all these ESS. And that's exactly what we're doing here. So we take all those ESS that we created and we create something called the GWP aggregate. And GWP stands for Garment Workers Productivity, which is the name of the dataset, as I said earlier. So we also go ahead and insert that aggregate. And then what we can do is we can take that aggregate and create a new aggregate that comprises of the former aggregate and then the actual productivity, which is usually the target value in this data set, as I showed earlier, the actual productivity. So we now combine the GWP aggregate from before and this new actual productivity. So what exactly is an aggregate and what does it look like? So we're going to see what it looks like down the line, but just think of it as a combination think of it as a combination of multiple vectors into one single vector. And that's exactly what we're doing. But in terms of the ESS, it also comes with some other information that is useful and informative. So this is an example of a multi-level aggregate where we create the GWP aggregate, which comprises of a lower level we create with GWP record rather, which comprises of a lower level aggregate called the GWP aggregate. So these two ESS make up the GWP aggregate, whereas these other ESS here make up the GWP aggregate. So now we can go ahead and insert all this data in our database. And here we're just using a loop to run through the data set that we have, and we'll go ahead and create that. So we'll just give that a few seconds to run, and we'll pick it up when it's done. Okay, so now that that is done, I should mention that we are actually interacting with an AveniECA server instance that's running. So that's just a quick note, and all this is possible because we logged in at this point to retrieve our API token so we can interact with the REST API directly. So let's see how we can retrieve information from our multi-level aggregates. So let's say we wanted to know the days that we had a team size of 8. Wanted to know the actual productivity on those days. And what we can do is we can search for the days that we had a state of 8. And for example, I'm just limiting it to 3 here for the sake of our demo. We could get more results if we want. And so here I'm just printing the first value, and this is what the ESS looks like for the team ESS. So most of these aggregate values are empty because it's not an aggregate, but then we have the state, and we have the ID, and we have the score, which is the number of times this state occurs. So what we can just do is take that ID for this state 8, and then we now want to know how many times, or we want to get the corresponding values for the rest of the ESS where that has a state of 8. So what we do is we use the get all aggregates API, and we specify the module ID as team, and then we specify the aggregate module ID as the GWP aggregate, which, if you remember, is the aggregate that we set the team as a member of. So here we specify the ESS ID for that team state of 8 here. And we can go ahead and run this, and we're just going to print the length of the results that we get back. So of course, no surprise, this is the same thing as the frequency. So we have the number of times this ESS appears is the number of times we'll have a GWP aggregate that contains that particular ESS. But now what we can now do is we can say, okay, from here we can you can take these results and iterate over it and get the actual productivity for each of those days. So for instance, I can just take the very first result here, and I can print that, and I have the index that contains that particular the index for that particular GWP aggregate. And so what I'll do is I'll use the Pretty API to see what this GWP aggregate looks like, and I can go ahead and run this. And now this is what the aggregate looks like. So here we have the aggregate state, which shows you the corresponding values for the rest of the values in that aggregate, including our state 8. And then you also have some other information, the aggregate score, which is the number, the frequency, the aggregate, the module IDs, which is useful to identify each of these states. You have the aggregate valence, the aggregate shape. And so, for example, if you look at the aggregate score, we can see that we can see the number of times each of these values appears or occurs in our data set or our database. So this is an example of what the aggregate looks like. And so now that we have the GWP aggregate, we can now reach for the GWP record, which is a level higher. And so we can just take this ID here and we can do the same thing that we did using the get-all aggregates, but this time the module ID will be the GWP aggregate, and then we're reaching for the aggregate above, which is the GWP record. So if we go ahead and just, if we print out this value, we'll have a very large value because the state will be a combination of these very large vectors, which, as you can see, the aggregate shape here will be quite large. So we won't do that, but we can just go ahead and print the ID, for example, just to be sure that we are getting a result back here. And then if we wanted to know the actual productivity for this GWP aggregate, we could just, because we know that the actual productivity is at the very last the very last state, we can just use this simple way to get the actual productivity for that particular day. So this is just a very simple example of how you can tie together multi-level aggregates and see how the information is nested within each aggregate. So in future versions of the software, it might be possible to see a pretty version of a very top level aggregate. But for now, the algorithm is not recursive. So if we were to, for instance, print this response, we would have a very large value that showed what that large state vector looks like. So that's it for this demo, and what we've illustrated here is just a simple way to think about aggregating multiple data sources into a single aggregate and then nesting that into a multi-level aggregate. And you can link different sources of information together using multi-level aggregates. So that's it for this demo. Thanks.